Hey people. No, I'm not 15 minutes early today. Let me adjust that. No, sometimes you have good days, sometimes you have bad days. This is a bad day, so I'm very disorganized and I have a little bit of a headache and other aches and welcome to life. Anyway, we're here. We've got lots of DC-DC converters and let's string some stuff together and see what happens. But we're still a few minutes early. Hey, come on. Let's see some chat. We've got some 15 and 20 meter runs of 5-volt strip, and I want to do the buck approach. Is something that I'm ready to experiment with. Well, that's something we're ready to experiment with too. And we're going to do that today, so stay tuned. You're in the right stream. Nothing a Coke Zero can't fix. And it is the return of the flavored Coke Zero. So today we have vanilla. I'm gonna crack it open. We have a few minutes. Let's have a drink. Relax a little bit. One of the other reasons I'm annoyed is that remember that heating system I have in the house that I was gonna replace and then never did? Or rather, I did some work for it and then I didn't, and I stopped and I started it again. And well, I'm making concrete plans to actually do it next year because it is currently 14 degrees outside, or 12 or something like that, but it's 26 degrees in the garage because Honeywell logic. For some reason, it decided to heat the whole garage to 26 degrees while the rest of the house is a comfy 21, 22. I don't know what's different about this room. All the sensors don't know what's different about this room, but it decided to do so anyway. So it's hot, I have a headache, and I'm majorly annoyed. So I guess that's a good start of any live stream, isn't it? Oh, man. You know what's not good? Like when you're annoyed and then combined with a lot of heat. It's never good. So I'm just going to enjoy my Coke Zero vanilla. Oh. So let's see who's here. Oh, I was just talking about how I was doing Tech Turtle. Oh, Johnny's here. I have something special coming in, Johnny. And it will probably in a Queen boxed first, and then we'll look at it during a live stream. But it's especially attuned to your favorite color. I can't say much else than that, but I saw it and it's like, I have to get this. Johnny wouldn't forgive me if I didn't. So, it's coming. Oh, let's see here. Tommy Tom Mastini. Wow, that's a lot of Toms there. Richard Campbell, Andrew McCurieski. Why am I reading names? I'm really bad at this. Oh, Philip is here. Nice. With him, beer music. No, don't have beer. Adam Bryant, lots of people here. Nice. Pink wires. No, we already had pink wires. I have a giant amount of pink wires. Look at my pink wire stash. I mean, come on. I don't think anyone has more pink wire than I have. This is at least 100 meters of pink wire, maybe more. I don't remember actually. And it's nice silicone wire too. It is very thin though. I basically bought it for single wire for LEDs and stuff like that. But this is, well, it should be on here somewhere. Oh, wait, it's in white. The way around. Yeah, this is 26 gauge. So that's pretty thin, but it's perfect for signal wires and all kinds of other short wires. Or tiny wires, thin wires. I have it in green too. Yeah, so we've got pink wires, but I've got something else coming that is in Johnny's favorite colors. So, hey. Sounds like Finland indeed, but sauna is a bit hotter. True. It is snowing here at the moment. Oh, and it's not snowing here. It's just drooly, wet, dark, damp, nasty weather over here. I don't like these seasons. I like the winter when it's snowing. I don't like it's almost cold but not really, and damp seasons. I don't like those. But yeah. Thanks for doing this. I may be on a journey you don't approve. I have 12 6812 strips, 60 meters in total. Wow, is that 5 volt or 12 volt? Hey, from Belgium, nice. Yeah, Dutch, BE, UK. I think UK is even worse than the Netherlands. Brian Law online yet? I don't know if he's online yet. Hey, Blaz is here. 5 volt, of course. Well, then you really want to do something with buck converters, because 60 meters 5 volt, you'll need cable the size of your arm. I mean, I don't know how much copper that's going to need, but that's not going to work. How about a Tuya stream? I'm fighting with issues. I've only got videos on Tuya Convert. I don't have anything Tuya left Tuya, so can't help you there. Greetings from Germany. Same weather here. Awful. Yeah, I don't think anyone likes this type of weather. Good evening from Berlicum. Teacher Gone Tech. That's a cool name. Live from Almere next to the drive-in. Playing It Chapter 2. Nice. Oh, and Arun Ankum says, yes, I got 4 of those buck converters for QuinLED data boosters. The data boosters, and we're talking about this little board, they've been selling like crazy. I had a few thousand made because of minimum order quantities and setup costs and stuff like that. I was like, we'll see what happens. But especially at Dr. Z's, they've been flying out of the door. And I've been hearing a lot of positive feedbacks of people who fixed their problems with it. So I'm very happy with that. Oh, Brian is putting his new Trinity board online for sale today. Well, sadly, Johnny, you're a bigger YouTuber than I am, because you received it. I saw that on Twitter, but I didn't. I mean, I just have bunch and stacks of LED strip, but no Trinity board for me. What's up with that, Brian? No, just kidding. Do we have people from all continents here tonight? Well, Europe is certainly represented, and America is for sure. I don't know. I don't know if the other continents are here. Do we have someone from Australia? So anyway, let's dive into it a little bit, because we do have something we want to accomplish today. So we looked at these buck converters last time. So we had a small 5 amp one, then we had a bigger 5 amp one. We had a same size 10 amp one, but the internals were definitely different versus the 5 amp one, because this at 6 amp got a whole lot hotter than this one at 10 amp. And then we have this beefy boy 5 volt 15 amp here, which almost didn't register any heat at all. So we have different sizes here, and well, oh, hey, David Howes is from Australia. So we've got Australia. Not an American Indian, but a real one. Oh, okay. I'm from Indian, Arizona. UK, cool. I'm not sure what... You have to forgive my head right now, Tech Turtle. What did we talk about? Got my second shipment of fairy pixels last week, says Teacher Gone Tech. Gonna replicate your Christmas tree from last year with 800 LEDs. Nice. We're gonna do that again this year, because those little tiny pixel dots, those are awesome. Let me show everyone. Can I do a browser grab? I should be able to. Let's go here. That's not what I want. And let's go here. So if you go to my webpage, it's not filling the screen. There we go. If you go to my webpage and you go to the digital LED, digitally addressable LEDs section, and you can do that by clicking the header here, or the picture here, or the go to section here. A lot of people seem to miss that. But anyway, let's go there. And there I have a guide specifically on my DIY addressable Christmas tree. And well, this is a nice picture of it, what it actually looked like. And I go through all the videos I did on those tiny little special pixels. They're a very special little LED with almost invisible wires attached to it. And I go through how I did all my injections and how I wired all that up in the tree. And I used the Dig-Quad for it in the end because I needed multiple data channels. And I needed multiple injections. And yeah, so the result and, well, the real world result. And it looks excellent. It's a bit of work to set it up because you have to wire it all and stuff like that. But after that, you just have a few hundred addressable pixels. And, well, the results speak for themselves. It's really nice. So if you're looking to do something like that yourself, look at the guide here. Will there be a guide for the V3 DIY version of the Dig-Uno? If yes, when? So the V3 Dig-Uno hasn't been, DIY hasn't been made available yet. I have started plans on that. Partially that's been extended because there's going to be a few small changes to the Dig-Quad board for the pre-assembled. And then I also want to take those changes over to the DIY version of that board. So kind of all needs to intersect. And basically what we're going to do, one of the things that's going to change, the design changed slightly. Wait, I should put it here. But we're also, I'm going to move forward with these big terminals on the next batch. I'm not sure when that's going to be yet, but yeah, that will come. So, and yeah, at some point I'll update the DIY versions, but I don't know when yet. So, because it's a lot of work, and there's a lot of work lying around for me, so it's kind of tough finding time doing that and doing the videos and preparing live streams and making new designs like the AN Penta and stuff like that. But yeah, the new terminals are I like them too. That's why we're moving forward with it, because hey, guess what? It's my product. So yeah, there's lots of stuff going on, and at some point I will find time to update the DIY designs, but there's not going to be too much changes on that. All the auto circuits and stuff like that that are on the pre-assembled versions will not come to the DIY versions because I just can't build it on there with DIY components, basically. So there will be an update in the pinout mostly. That's generally going to be it, and the Dig-Quad DIY will get the DC-DC converter from the Dig-Uno and some other small changes, but again, mostly pinout and stuff like that. So that's why I haven't changed the DIY yet, because not that much is going to change. So yeah. Anyway, we'll work on that some other time. 30 seconds delay. Oh, that's a lot. Russia. Someone from Russia here? 6:20 a.m. Wow. No, there's no part list for the AN Penta yet. I'm doing, I've actually worked today on doing the final revision for the DIY version, and then I'll start working on getting that released. But there's hundreds of hours of work in designing and then doing the articles and stuff like that. What we do have, and we can look at that, is I have made the specification article in the analog dimmer section for the AN Penta available. It's still a little bit under construction article, but it does list all the features and stuff like that. Power handling I go into, and yeah. So I have been putting out information on the AN Penta already. And yeah, lots of stuff going on in the background, that's for sure. So today, what we're going to do today, we have, I should have multiple of these. Yeah, so I have 3 bags here of WS2812 strip, right? So let's get those out of the bag. Let me do the top-down view, I guess. Okay, oh, no, this is weather sealed, that's fine. Okay. Quinware! I don't know, maybe if I ever hit 100k YouTube subscribers, which with the current rate of growth will be like in an eon or so, because I haven't really been putting out videos to get more subscribers. I've been putting out videos with good technical data, but those two basically don't align. They're not exciting, so then it doesn't get promoted to other people, and then the channel doesn't really grow, but I'm pretty happy where I am with 40,000 subscribers, so it's okay. I'd rather put out good technical content which actually helps people that watch it, instead of fluff tech content like a lot of other YouTubers do. But look at these new lights from Govee. Okay, yeah, sure, they're still boring, but okay. So anyway, yes. Will there be some USB-C stuff tonight? No, but I have been working on it. That's been in the background, and there's been some movement in that regard. So there will be in the future, but not right now. Yes, meanwhile, PSUs are good. We actually had 2 or 3 cases this week alone where people had issues with their LEDs, and it all turned out to be either faulty power supplies, and in one case it was not enough power wires going from the power supply to the board, basically. Oh, just started recording a mailbag video today. It's a bit short with 6 packages, says Adam Bryant. I've actually been slowed down with packages a little bit, so they're accumulating again now. I should be able to do a Quinbox soon. I don't know when yet. Anyway, we have these 3 strips, right? So, what direction are they? Okay, so they go from the outside. And we have a 24 volt power supply. This should be, yep, UHP 24. Not sure you can see that, but it's the 24 volt version, so that's good. Let me plug that in real quick, but the socket is still turned off. Okay, and okay, let's start with wiring up the QuinLED, and then we'll continue wiring, I guess. So from the power supply, these aren't very thick. They're 18 gauge, but since we're doing 24 volts, 18 gauge is pretty good. And I've actually prepared a whole bunch of 18 gauge we're going to use, and for signal wires we're going to use this 26 gauge. With the favorite colors of Johnny, hey. And, yeah, so let's hook up the QuinLED board. And we're going to use the prototype again. Functionality-wise, there isn't anything different than what's on the current boards, but yeah. These are all fully 24 volt compatible. So you can feed 24 volt directly into the board. But always beware that in case you're running power directly to the LEDs, that the input voltage needs to be the same as the output voltage. Or sorry, the input voltage needs to be the same as your LED voltage. This board does all kinds of DC conversions, but only for itself. It's very selfish. It tries to keep itself alive, but if you feed it 24 volts, the board will be fine. But if you then connect 5 volt LEDs behind it, those will fry for, you know, their life. So yeah, always be mindful that input voltage needs to is output voltage. I should replace these fuses. Yeah, maybe I should. Should I replace these fuses, or we're going to YOLO it? Nah, let's replace the fuses. Yako says, planning on building a van. Yes, I know, it's van life is so 2020. Should be interesting with a 12 volt house battery. We'll do analog 12 volt main lighting though. But some color here or there is always fun. Yeah, you can do that analog too. Or you can go the digital route. And often if the voltage is between 11 and 14 volts, a buck converter setup like we're building isn't a bad choice. So, hey. Let me get some lower amount fuses. They're in my box of fuses. There we go, box of fuses. 5 amp, no. 2 amp. 2 amp is good, I guess. Well, that's 48 watts. Do I have something else? What's this? No. I'd like some 3 amp fuses, but I don't have it. I'll put 5 amp fuses in it. Yeah. Oh. For fun, I'll put 1 2 amp in, and then the rest 5 amp, and we'll see what happens. Oh, no. And these are my good quality fuses, because I've tested them and I know they'll blow at their ratings pretty quickly. So, yeah. Let's just put that here for now. Where's my music? Okay. Let's see here. So we're going to do 5 amp here. It's not been asked in this live stream yet. He sold through his Dig-Quads pretty quickly at Dr. Z's. We're working on getting a new batch produced, but that'll take at least until, let's say, the beginning of November. So Worldwide still has some Dig-Quads left, but they're also selling quickly there. So if you need them before somewhere in November, I'd suggest ordering them from Worldwide. If you can wait until somewhere in November, then we should have new stock at Dr. Z's and in Worldwide too. So it all depends on when you need it. Right. So how are we going to do this? We have our Dig-Quad, which has now been fused for 24 volts, if that is a thing. And, well, I guess we need to hook up a strip. But let's say that the beginning of a strip will do 5 amps. And then let's start with the scenario where we hook up everything together. So we've crossed or interconnected positive voltage. While in actuality, you probably shouldn't do that. But let's test that. Let's see what happens. Right. And so then we need, after the first strip, because we want to inject front and back on 5 volt strip, we're going to do another injector here, and this is going to be a 10 amp one. And then we're going to take the 15 amp one, and we're going to do that here. And then we'll take, well, I don't know, another one of those, and we'll do that on the, well, you can't even see that, on the back end, basically. So Dig-Quad, first injection line to the front, then second injection line to the middle, and then a third injection line to the middle here, and then a fourth injection line to the end, basically. Right? I hope that makes sense. And all those lines are going to be 24 volt, so we're not too worried about wire gauge and stuff like that. So let me just wire up the first part. Let's start with that, and then we'll just move on from there, right? And I think I'm just going to take the easy route, and that is hooking this one up directly without any wire in between. Is that cheating? I guess that's cheating, but I don't care. I'm going to do it anyway. Okay, so let's just... I don't want to put ferrules on everything if I don't have to. These are tinned. And these are using some of the new screw terminals we're going to replace on the boards also soon. So this should fit pretty good. Okay. Yep, that's fine. That's the output. Oh no! You're right. You're right. Not paying attention today. Yeah, we shouldn't see too much smoke today. Let's hope not. We'll see. And one of the things that will be interesting today is if we can connect the positive lines together or not. Theory says we shouldn't really, because that way the DC-DC converters will, in theory, start load sharing. And, well, we kind of don't want that because they're not designed to do that. So, yeah. Okay, and now the output wires, but I need some DuPont wires for that, or DuPont wires. I need some connection blocks for that to make it easy. Because let's do ground here and positive here, and let's use we can use one of these, I guess. Do I have a prepared one here? No. Also no, but might need it later. Nope. I thought I had some, but I simply don't. Oh wait, here they are. Okay. Let's take this one, because we can connect it to the LED strip like so. We will connect power through the DC-DC converter. Oh, that's fine. And also minus. And then we'll just wire up the data connection directly. And we're only going to use one data connection for now. We might need a second one later, but we'll look at that. Okay, so what do we have? We have a Dig-Quad with positive 24 volts going. You guys really aren't paying attention, are you? I'm not either, so can't blame you. I actually wired up the board in reverse. Nothing will happen. It's been designed to be protected against that, but it's not good. Wow, I mean, when I have a headache, things don't work in my head, as is probably obvious by now. I wired up the negative wires to the positive terminals and vice versa. Oh. Anyway, it would have been protected. No worries, but yeah, Johnny, that's correct. We don't want one, in this case, DC-DC converter to backfeed into the other DC-DC converter, and even worse, maybe influence the regulator of the DC-DC converter, which often works with a feedback loop. If it would see pulsing from the other regulators, that might create some kind of feedback loop in the buck regulators themselves. But we're just going to try that today and see what happens. It could be that the resistance in the LED strip will be enough for it not to really be a problem. That doesn't mean it's good to do, but at least maybe it won't blow up when you do it, basically. Okay, let's look at this again. Now we have the right power wires going into the right terminal. So positive comes in here. This is also positive, good. It goes through the fuses. It comes out of here. It's still 24 volts. It goes into the input side, thank you, Philip, for the DC converter. This is a 5 amp block. And then it goes to the LED strip with a little connector in between. And we've just connected data directly because we don't really care about that right now, right? I don't know if I reflashed this this ESP32 or not. But let's just turn it on, see what happens. Okay. Well, we have light. That's good. Let's see if it got onto the wireless. I think so. Can I change the light? No. Let's see what's in here. Oh, okay, this is very different. Let me show you that. So let's set this up for 900 LEDs. That's a bit too much for one data channel, but we're going to do it anyway. And then we have 300 times WS28. Okay, that is the correct pin. This should be 3, I think, and this should be 1. This is 300. Is that correct? Yes. Should this be 301? Don't know. Don't think so. Because it starts at 0. Yeah. Okay. Let's save that. Okay, then I got my color order wrong. So if you're ever faced with having the wrong colors in the LEDs, because this should be orange, it's likely that the color order, which is now GRB, should be either RGB or BRG or RBG or BGR or... Let's try RGB. Nope, still wrong color. Should be orange. Let's try BRG. Now it's orange. And if we go back and... Oh, it wasn't set to orange, damn it. Okay, red. Blue is green. That's not good. So we go back to config. And we say if blue is green, so B and G should be reversed. So it should be this one. Okay, let's try it again. Red, blue, green. Okay, so if you ever have different LED strips, will use different ways of addressing the colors, basically. And yeah. You're about to run 10 meters of SK6812, 144. Oh, wow, that's a lot of LEDs. 900 LEDs, YOLO. Oh, yeah. So, okay, so this works. Let's see what it draws at white. That's about 23 watts. Okay. Well, the reason I chose a 5 amp one here is because this is an edge connection. And the next connection we're going to do, so over here, will be a middle connection. So basically what we're going to do is very simple. We're going to, let me show you. We're just going to connect these together. I did it wrong. I did it wrong. I shouldn't have put them on multiple interfaces. Minus, I want 900 LEDs on a single pin. Oh no, you shouldn't do that because you're going to get lag, blah, blah, blah. Yeah, I know. But we're going to do it anyway. Okay, there we go. So you can already tell probably that this right one is a lot dimmer than the left one. And that's because, well, the voltage drop is going to be insane right now. I'm going to turn it off and then we're going to strip the injection wires you often get on the strip. And we're going to use that to inject power. I have to reset it. And we should also have the same wires on the other strip, because it's best to use all the wires you can, basically. If I can reach those. Normally it wouldn't be on the spool, so then it'd be easier. I can reach it. It's okay. So let's put some ferrules in these and then connect it up. Now these are very thin wires, but because they're so short, they'll work okay. You definitely shouldn't run these the distance unless you're using 24 volts maybe. Oh, come on. You know what? I'm not going to bother, am I going to bother? No, I'm not going to bother putting ferrules on it for once. Let's see how it works out. So I'm just going to put it into this block. There we go. It's very not me, not putting ferrules on stuff, but there we go. feels like it's a solid connection. Now let's do the same for the other strip. Let's turn this around a little bit. Okay, so now we have a little splitter block so that we have plus from both strips and minus from both strips. And we can connect in our DC-DC converter. Yeah, true that running them on the spool is in theory a bad thing. Now for digitally addressable LEDs, it's much less of an issue than for analog LEDs. Analog LEDs, I've literally melted spools before. But if we're just going to do some test patterns and stuff like that, or do it for like 10 or 30 seconds, digital LEDs will be okay. Analog LEDs, it's definitely a different case because those will run you very hot. But it's a good point to highlight. You shouldn't generally run your LEDs while it's still on the spool because they will not be able to radiate their heat and will die quicker, basically. And with analog LEDs, they can literally go up in smoke. Okay, so... Oh, okay, yeah, got this to fit. It's good. Again, I'm not going to bother with wires in between because we looked at the wires in between last time, so we kind of know what the influence of the wires is. And even if we're sending out 24 volts from the Dig-Quad in this case, if it's like 16 or 18 volts once it reaches this converter, it's still fine because it only needs to convert to 5 volts, so that's fine. Now let's see if we can get this into a terminal. Oh, yes we can. I guess it's non-ferrule day. I'm sending all the wrong examples today, Philip. I'm not using ferrules on everything, and I'm not unspooling the LED strip. Oh, so bad, so bad. Let me read chat for a little bit. Should we use diodes to prevent any DC feedback? Oh, that's an interesting use case, actually. I guess that would work. Not sure. Yeah, we're just going to see what it does. Will the data signal be 24 volt? No, data signals are always 5 volt, even on addressable 24 volt strip. And I guess that will be... I will have another tease for you at the end of this stream. Yeah, headache plus bad day plus live stream is how normal people do it, right? Yeah, so, okay, now we have two strips. Both are getting 24 volt from the Dig-Quad. First to this one on a edge connection and this one on a middle connection. That's why this one is 10 amps and this one is 5 amps. And we only have a single data connection because we're just going to connect data over here. And we use the little connection block to go from the output positive to the red, and then black is always negative, or on LED strips it's white, for instance. Fine. Okay. Let me unfurl this a little bit. There we go. Let's see what happens. Okay. Well, it lights up. That's good. We're drawing 32 watts. Okay. And if we would now want to know if it's actually doing something, we can set my meter, and let's zero that. Okay. And let's see what it does here. Okay, so this DC-DC converter is currently giving off 3.5 amps, almost 3.4 something. And this DC-DC converter is doing 1.1. Okay. But the problem now is, because the positives are connected, and it does seem to work, that's okay. What happens when one DC-DC converter fails? So basically, if I just pull out this wire, Well, that's a bit unexpected. Oh wait, I'm measuring the minus wire. Why am I doing that? Hold on. I should be measuring the positive wire, of course. And I have to disconnect both wires here. So let's say that one of the wires fails. Or two of the wires fail. What? I guess nothing much happens. Interesting. Interesting. So this is now at 1.2 amps. And this is at 3.6 and a bit. Now, we're still at 50% orange. This is still not very hot for digital LEDs. But sure, I'll put a nice effect for you guys. I like the palette effect, for instance. And let's lower brightness a little bit. There we go. So it does seem like this connection's loose. Okay, better. Because you can definitely see the difference in color there. But it does seem like they're kind of balancing. Let's go to full power for a little bit, not too long. So full power, this is drawing about 5 amps. Okay, sure. And this one is doing 1.7, 1.8. Okay, but that's normal because, as I said, this is an edge connection and this is a middle connection. And the middle connection will always have more drawn, especially since we connected the power wires of both through the splitter block. Yep. We can also look at the voltage, but it should be pretty good now. So let's see here. Right, because we're measuring basically at the output of a DC-DC converter. So we're measuring a perfect 5.17 volts. And I can't easily measure on this block because I can't stick the pins in here. But this one is also going to be giving off 5 volts. So, yeah. So far, it's not that big of an issue. But let's say this DC-DC converter failed. Oh, well, it failed now because the wire came out. Oh, no. That ferrule crimp wasn't very good. That's probably why it wasn't drawing that much. It wasn't connected anymore. Oh, today is not my day. Let's measure it again. Okay. That's not very logical, is it? Is it disconnected again? Let's lower it in power. That's connected. That's connected. That's connected. That's connected. So did this one take over everything? So let's measure now. That's 1 point something. Okay, sure. And then let's measure here. It's 0.3. That's not a lot. Okay, let's power up again. Okay, so now it's doing something. That's good. So the reason that it's expected that the middle is going to draw more is because basically power can travel both ways. So it can travel into this strip, but it can also travel into this strip. And if the strip is the limiting factor in how much power it can draw because of voltage drop, well, it has twice as much of copper close to it than an edge connection will. Does that make sense? So power flows both ways, and thus it has twice the amount of copper to spread, and thus it can basically draw double if voltage drop is the same over the amount of copper, because we have double the amount of copper next to our connection points. Cool. Okay. So far, this seems to be working fine, but how do we simulate if something goes wrong? Okay, let's put it full power, right? We're drawing 44 watts from the socket. And now let's disconnect this one. We're now drawing 26 watts from the socket. And now let's disconnect this one. We're now drawing 21 watts from the socket. That means that now everything is being supplied by this DC-DC converter. And that is in part the reason why you don't want a setup like this. Because if this DC-DC converter wouldn't have a limit, it could potentially be being overdrawn, basically. Because now it's delivering almost 3 amps instead of the 1 point something that it did before. Now, it's a 5 amp converter, so that's no problem. So maybe you can connect everything together as long as you make sure that each individual converter can survive if one of the others fails. We can think about that. Is that a decent conclusion? So just connecting ground already helps a lot. And then connecting the extra 5 volt really brightens them up. Oh wait, I guess if I disconnect this one, so I disconnected the middle positive, we can still measure voltage. Yeah. It's at 3.1, oh wait, 3.2 volts because it's have to go into the strip. But if I now also disconnect negative, yeah, now it's at 2.6 volts. So we're injecting 5 volt here, but then because it has to travel all the way through the strip, even running a little pattern and stuff like that, it's down to 2.7 volts. I'm amazed these still work, actually. But yeah, so that is the issue with having multiple converters on the same positive rail. If one of them fails and the other one then tries to compensate for that, but it can't handle it, or the cables in between can't handle it, or something like that, that can potentially cause an issue that you need to watch out for. Yeah, that's about right. 1/4 and 3/4, but yeah. We've had issues? What kind of issues? What if the ground is connected with no ground? You mean disconnect this ground? Then I would imagine... Yeah, what is it doing now? Interesting. That's a good question. It's supplying 2.5 amps. Okay. And this side is now supplying 1.3 amps. Can I measure the ground? I guess I can. Yeah, so now this ground is drawing 3.8 amps. So we have a very mixed load, basically. But this is still doing something because it's getting the ground from here. And of course the input ground is still connected. I can disconnect the input ground, see what happens there. But you can immediately see the difference in brightness, right? Oh, YouTube stream disconnected multiple times. Okay. Yeah, ground's flowing back the wrong way. That's right. Let me view my stats. I've missed 2 frames due to rendering lag and 2 frames due to encoding lag. But I have 0 dropped frames on the network. Don't know. That sounds good to me. Right, so let's disconnect the input ground from this converter and see what happens. Okay, I can just leave this here. There we go. So it's currently doing 5 amps over the positive end. And now I'm going to disconnect the ground wire. It's still doing 5 amps and a little bit over the converter. Of course, it's now getting ground from there. But this ground is definitely disconnected. So let me measure the ground over here. That's not doing a lot of ground. Interesting. So let's reconnect it. So currently it's doing 4.4 on the ground. And now it's doing 5 something on the ground. Okay. So far this seems slightly less dangerous than you'd imagine. Partly because it's still the same power supply, of course, but right. Let's continue, and let's just hook up another set. So we just hook up a third strip. There we go. Let's just take another of these blocks. Okay, I have to turn it off to snip off the wires. 1 second, please. Okay. Let's snip off these wires here. Yeah, generally all grounds are connected, Timo. And I think in this case they are too. Right, so let's put them in the blocks again. Okay, those are done. Okay, so let's get a the really beefy converter, although it's on the edge. Let's stick with the plastic versions. Do I have a 5 amp one? Yeah, I have a 5 amp one. Here, we'll take another 5 amp one. Need my scissors. So then we're going to have oh right, this is supposed to be an official middle connection, right? Okay, let's put a 10 amp here and then is this? I'm confused. Yeah, this is a middle injection. Right, so for the middle injection we're going to take a 10 amp one. Are you an advert for Brian, Johnny? It's okay. I like Brian, so all good there. All good there. Okay, so this is another middle connection, so we're using a 10 amp one, not a 5 amp one. Okay, let's connect the output wires. Yeah, big YouTubers. I'm not a big YouTuber. I'm small fries. Okay, and let's connect the input. Because I'm not using wires, it's going to be a little mess, but it's okay. Come on. But adding wires would make it even more complex to do it just on the table. Right, so to resume, we have an initial connection, initial edge connection going to a 5 amp block, which is then fed into this LED strip here. 300 LEDs later, WS2812B. We have a middle connection, which is being fed through this 10 amp block, which is then feeding both these strips with the power injection wires, and it's connected, so everything there is connected. Then it goes to another 300 LEDs. Then we have another 10 amp middle injection. We also have the LED strip connected, so all the positives and all the negatives, they're all connected. And we're not using fuses on anything on this side, which is never a good plan, but we do have fuses here. So if something would very roughly overdraw something, the fuses here would still pop. So that's good. We don't have an edge connection yet. We can do that later because per 300 LEDs you want to inject front and end with another 5 amp converter, but we don't have that one yet. Okay, let's see if this works. You skipped every other one than 10 amp mid injectors? I'm confused. Oh, you think 5 amp for each injector would be fine how I have it. That depends. 300 WS2812B LEDs can use up to 13 amps. So a middle injector will do, well, it'll go left and right, so it could easily feed like 200 on the left and 200 on the right. And then even 10 amps officially wouldn't be enough if you do full brightness white. Now, generally you don't do that, but let's say currently this seems to still be working fine. We can quickly do that. So if I go here, I set it to solid. Let's set it to white. That's my multimeter. We're now drawing 85 watts, but it's only at 50%. And now we're drawing 133 watts. Now, I'm not going to do that very long. If we take the calculator and we calculate 133 divided by 24, that means we're asking 5.5 amps from the power supplies, or the wires that are over here, basically. So wires from here to the blocks are only needing to transport 5.5 amps in total. But if we take that 133 and we divide it by 5, that means we're drawing 26 watts. Or, no, that means we're drawing 26 amps. And, well, set to white, these do become hot. But 26 amps is 10 plus 10 plus 5. So, no. You do want 10 amp converters in the middle, basically. That's what I'm saying. No, so I don't agree, Blake and Patrick, that 5 amp would be fine because, well, 133 watts incoming, sure, there's some conversion loss somewhere, but that's 26 amps at 5 volt. So if these would have been 5 amp converters, that wouldn't have worked, or they would have been heavily overdrawn. And especially if one would fail, the other one would be even more overdrawn. So I'd always caution on the high side, getting 1 or 2 models above what you think you'll need, versus what you think you could get away with. Maybe, yeah, because if we look at my power, wait. So if we look at QuinLED.info and we go to the addressable LED section again, and we look at my digital LED power usage sheet, and we go to the 5 volt sheet, we see that WS2812B at 100% white uses 65 watts. The sheets are all in watts because you can then easily compare between 5 volt, 12 volt, and 24 volt LED strips. So watts is always the same, and then you can just divide it by the voltage you're running to find the amps. And 65 divided by 5 is 13. So one of these rolls, if properly injected, and all my tests at 5 volt are done with a front, middle, and end connection, will draw up to 65 watts, or amps, well, 65 watt or 13 amps full white. Now, if you look at the other patterns like police all or loading or even rainbow or a single color, we see it's only drawing 25 watts. So that's a whole lot less. But maybe if something soft or white goes wrong and all the LEDs suddenly jump to white, you do want to be slightly prepared for that scenario. Either by fusing pretty low and then popping a fuse, or just making sure the setup can handle it. Yeah, these are all measured numbers of these actual strips. So, let's see. Let's do a little bit of chat. We'll hook up the last converter in a little bit. What about 300 WS28 11 pixels? Can you inject after the first 100 only, or would begin and end be best? Oh, if 300. Are they resistor pixels or regulated pixels? Because if we go back to my power measurement sheet and we go to the 12 volt section, and then we have single addressable 100 LED pixels, those can use just those 100 up to 67 watts. So again, that's around 13 to 14 amps. No, that's around roughly 13 amps. Oh yeah, I assumed his 2811 pixels were 12 volt. And as I say it, if you want to do full RGB white, you should do front and end injections per 2 strips. Oh, wait. Per 200, so that's 2 strings of 100. Or if just normal colors and stuff like that is okay, you can do front and end with regulated pixels with 300 in between. Right, so if you do only colors and patterns, you're not going to exceed like the 28 watt, or yeah, here you can inject front and end over 300, but if you do want to be able to do white, you can front and end inject over 200, and then since you're injecting this end, but it's actually a middle, that'll probably work out at 12 volt. At 5 volt it probably wouldn't, but at 12 volt it'll probably work out. I did not look at that yet, but we can do so. Let's put on a nice little pattern here. Let's go police all and give it half brightness. There we go. Where's the amp measure thingy? Zero that. So we can measure the amps here. So we're drawing 37 watts from the socket going to the power supply, and then we're doing 1.32 amps here. But that's at 24 volts, so 24 times 1.34 or 35, that's 32 watts, and the socket is saying 37 watts. Okay, there's some conversion loss there, of course. We can't, well, can we? Can we measure all these at the same time? No, this is all still 12 volt, or 24 volt. I can't measure all the 5 volts together. I can just see like, okay, this one is doing 2.7, okay. This one is doing 2.3, okay. And then this one is doing not a lot. Is this not doing anything? Let's disconnect it, see if it's not doing anything. We might not have a good connection here. That's what I get for not using ferrules. Let's measure it now. Nope. Okay. Why not? Let's measure the incoming side. It's minus? What's going on here? Hold on. Let me put that to full power. And let me disconnect it. Okay, we do see the change. Yeah. So it is working. It just didn't have to do anything. Oh, okay, we can do the 24 volt side at white. That's fine. And there we are. So the power socket is measuring 131 watts. And into the board, it says 5.0, no, let's say 5.1, right? So yeah, that's 5.1 amps at 24 volts. But divided to 5 volts, that's about, as I said, 25. Sure, but actually these don't have resistors in line 4chan 4pres because they're addressable LEDs and they generally work with a constant current type of LDO inside of the LED. But yeah. Oh, right. Sorry about that. Yeah, it's okay. After the... Oh, sure, we can do that. Let's put it to full white. There we go. And then after the converter, we're seeing about 9 amps here from one converter. That's also middle injection. Then we're seeing about 9 amps from this converter, also middle injection. And we're seeing about 3.45 amps from this one, but that's a front injection, so that's expected. Does that show it, Blake? Yeah, but it doesn't really matter if the meter shows minus or plus, in my opinion. So, okay, let me hook up the last converter. And, yeah. Then I think we'll have done all the tests we needed to do. And I'm actually surprised this is working as well as it does. And because of the resistance on the LED strip... Where did I put my strippers? Here they are. Sure, I can put a 10 amp there, but that's not going to make a difference if it's not even drawing 5 amps. Because we looked at the converters in the last live stream, and the converters are pretty good. The 5 amp one will definitely do 5 amp on the output if it's asked to. Any heat on the converters? Yeah, if you're driving these up to 10 amp, those will become slightly warm. The conclusion where we looked at the converters last live stream was that they're actually pretty good, and that they are pretty good at doing their rated currents. So the 5 amp one will do 5 amp without overheating, and the 10 amp one will do 10 amp without overheating. But if you're going to ask that much of them, as I just said, I'd step it up, and I'd maybe get one of these beefy ones that can do up to 15 amps output, even if you're just going to use 10 amps. We can actually replace one of the converters and see if that makes a difference later. Let me just hook this up real quick. Without any ferrules. Oh. Let's see. Output wires. And then we have input, of course. It's becoming a slight mess here. Yeah, the V2 pre-assembled can support 24 volts directly on the inputs like we're doing right now. The V1 or the current DIY version cannot. I do have some articles on my website how you can replace the capacitor on here and the linear regulators that are used on the DIY version and on the V1 for a buck converter. That's pretty easy to replace, and then the board can fully support 24 volt like the V2 is doing right now. But if you have a pre-assembled V2, that can do 24 volt, no problem, just like I'm showing you right now, basically. You need to pee, but you don't want to stop the stream. That's okay. So I planned on 2-meter injections with 10 amps converters at 144. Probably not enough then. Actually, I think it is. Because if you have a front injection, then you have 2 meters. That's 288 LEDs. And then you have a middle injection. And then you have another 2 meters. But let's say the middle only does half of left and half of right, because there's another injector at the same distance then. We're talking 288 LEDs, and that's not much different than we're doing here. So I think that'll work out pretty well, Blake. Did you cover why you don't tin wires on projects like this? Normally, I'd put ferrules on everything, like you can see here, for instance, and yeah. But I don't want to bother today for these tests. But normally, I'd put ferrules everywhere. I wouldn't tin the wires, because tinning is more prone to breaking, and a ferruled connection is generally better than a tinned connection. But yeah. Okay, let's hook this up. Turn it on. Okay. This looks okay. Well, let's go to full white, see if that makes a difference in power draw. Oh wow, it does. We're now at 150 watts drawn from the socket. And let's take a look at all the converters real quick. Ooh. This one is doing about 2 amps. This one is doing about 8 amps, so it's doing slightly less because the other converter is now closer, providing a higher voltage. So part of the LEDs are getting their power from there, and part of the LEDs are getting the power from here. This one is now doing about 9 amps, and this one is doing about 3.4 amps. And in total, we're looking at 5.19. Okay. Oh, power draw actually decreased. I think I might have disconnected something. Let me double check that. No, this is definitely connected. Interesting, we're only doing 134. But I'm pretty sure all the converters are working, because otherwise, let's say if I disconnect this one, you can, yeah, you can't really see. You can, maybe you can tell, yeah, you can tell in the brightness if I disconnect this one, the middle becomes dim because of the voltage drop, but if the converter is connected, it's evenly lit. Oh, if a fuse popped. No, I don't think so, but I can measure on the output terminals. So we put it somewhere on ground. Let's see here. This one is 24, 24, 24, 24, 24, 24, 24. Nope, fuses are good. These are not SK6812. These are WS2812B standard LEDs. The cheap stuff. Yeah, we're only still doing 133 watts. So 133 divided by 5, that is about 26.6 amps. Okay, sure. That sounds about right. Of course, this is testing worst case scenarios and stuff like that. If we're looking at doing a little pattern like this, it's only doing 0.6 amps on the 24 volt side, and I can max it out in brightness. And it's doing 1.5 amps on the 24 volt side. So that means we can use relatively thin cables because we're not gonna, we might have a little bit of drop on the 24 volt side, but on the 5 volt side, that 1.5 amps. So if we're seeing 1.5 amps at 24 volts, that is 36 watts. Okay, and if we then divide that by 5, that is 7.2 amps. Now, the cabling needed to transfer 7.2 amps is a lot thicker than 1.5 amp. And that's basically why we're doing this. Wow, if your tin is melting, you need to either use higher temperature tin or solder, or something else is going wrong, but yeah. Can you measure output amp on input of converter? Output amp on input of converter? I'm confused by that statement, but if you want me to measure one of the 24 volt lines going into the converter, and this is another one, it's not going to be much, 0.3, and this is 0.6, and this is 0.3 also. So that's normal. Edge uses less than middle. That's expected. Yeah. My LEDs are slightly hot because I've been running them in white patterns. Let's do it like this a little bit so they can breathe. What if one or two converters die? Will the full load be on one converter? Well, that is kind of the danger scenario here, that either if something dies, the load will be on a converter which could burn down, or a wire would take more amps than it was designed to. Yeah, the amps are stupid at 24 volts. It's just 5 volt that is causing all the amp issues always. So let's say this middle converter dies, and let's keep the amp meter on the other one. Right, so we have the first middle converter, that's this one, and then we have the second middle converter, that's this one, that's because those are the 10 amp ones. And then we have the last end converter. But let's say this one dies, right? And it dies by disconnecting the wire. Or wires. Okay, but we see the LED strip dim slightly because now there's more voltage drop going over the LED strip. And that'll in turn automatically also limit power. So we don't see a drastic amount of extra draw here. So let's connect that back. So we're now at about 3 amps. Okay, and we're now at 1.74. Okay, so we do see extra draw, but the extra draw isn't going to be unlimited because of the tiny amounts of copper on the LED strip, which will in turn limit power basically. Okay, and now let's see this edge converter here, which is only a 5 amp model. It's currently doing 0.7 amps. And now the middle converter closest to it, it fails. So let's pull that out. Okay, and now it's doing 0.89 amps. That's okay. A little bit more. And now this middle converter also failed. Yeah, it's not doing too much more. That's interesting. But then this one also failed. I don't know. Okay, yeah, okay. If I disconnect this converter, yeah, there's almost no bright. I mean, look at the brightness of this strip, which has this converter still, and look at the brightness of this strip. But if I reconnect that one, okay, the brightness comes back mostly. It's not fully bright, which I would expect. Oh, okay, the minus wire isn't connecting well enough. Let me fix this wire. No, that's definitely not working. Is it on the other side? Probably. Let's not connect everything. See, this is why you use ferrules. I know this. Didn't do it anyway. There. Now we have a good connection. Ah, finally. Right. So it's using 2.4 amps. And let's reconnect the middle injector that is closest to it on the positive side. And then it actually uses less, which is logical because now this injector is taking care of part of the job. And if I connect minus, it's taking less again. And if I do the same here, yeah, same is true here. So when I disconnect the middle injector that is close to here, you see that it starts using more power, but the amount of more power that it can actually use is limited by the voltage drop going over the strip. If this was a wire in between there, we might be overloading that wire, but since this is an LED strip which suffers from voltage drop anyway, the amount of extra current that will get drawn is pretty limited. Yes, correct, Philip. Thank you. Yeah, this is a prime example why you should use ferrules and not do what I do and just twist the wires and jam them into a connector, because then you think it's in there, but it's not making great contact, and yeah. So let's see if I now put it on white. Yeah, now we're also back to the 152 watts going in. And you can see that the edge converter is now delivering 4.43 amps. This one is delivering 8.5. This one is delivering 9. And this one is delivering 3.4. So that is about what we would calculate to be correct for that number. Yeah, currently for the Dig-Quad, worldwide is definitely best. If you want it within a month or so. We're doing another production run, but it'll be a while before that's done. So, yeah, if you need it before like a month, get it from worldwide until those are out too, and then everyone has to wait. Oh, this is a good idea as someone who just bought a bunch of HD 107S. Yeah, those are 5 volt too, and they can draw a lot of power. So definitely is. This setup is definitely, if you want to do a long setup but want to keep single addressable LEDs, it's kind of the only way to go, because after 10 to 15 meters, using 5 volt cables, you're going to need such thick cables that it just doesn't make sense anymore. Yeah, I know a Europe shop would be nice, and I've looked into it a few times, but basically I'd have to make a Dig-Uno or Dig-Quad about $10 more expensive if I sold them in Europe than if you bought them directly from China. So I know there's a slightly expensive shipping from China, but if I had them shipped to me, even in bulk, I'd have to pay shipping too, and then I'd have to pay import tax and fees, and then I'd have to sell it to you. Then we'd have transport fees anyways, and those are much cheaper than from China. And in the end, I worked out that buying boards locally in Europe, it would cost the end user probably around $10 more a board than if they bought them directly from China. And that's part of the reason why there's no Dutch shop or Europe shop or something like that. So, yeah. One of the things we can do is we can replace this connector, or this DC converter here, the 5 amp one, with a 15 amp one. and see if that makes a difference. I don't think it will. Because as I said, because of voltage drop, it's limited the amount of current it'll draw from a single injection point. And that's also what I teach you in my power injection streams. Calculate about 3 to 4 amps per injection, because that's the amount of power you kind of want to give. Because more than that, you'll just see a lot more voltage drop, and it basically won't do anything. You can't force power into an injection point. It'll only give so much as, well, the strip can handle, and generally between 3 to maybe 4.5 amps is a good value for that. So then you can also determine the amount of injection points you need. What's input and output again? Output. Okay. Let's see if we can get this in here. These are a bit tough wires. Well, I can get them into this terminal. That I'm pretty sure of. There we go. We might pop a fuse. We'll see. Oh no, now I need to get them into this terminal. Oh, there we go. 16 gauge can go in, but it's a bit tough. But we're working on getting different terminals which will do that better. Okay, now it's even more of a janky mess. Let's see here. Oh, 20 days from worldwide. That's pretty long. I don't know where you're living, but you should have it pretty soon. Generally, it's about 10 to 15 days. So. Okay, so let's put the amp meter on the output of this big converter here. There we go. Well, 1.32, that's about the same as the other converter was doing. Let's set it to white. And full power. Okay, we're seeing 4.3 something. That's about the same as we saw with the other converter. But this one can do up to 15 amps. But again, because it's an edge injection, you can only inject so much before the voltage drop basically takes over and it won't push any more power into the LED strip basically. So even with this big converter on this side, doesn't make a difference. This would have been helpful last year. I did 40 meters of APA 102C at 5 volt and used 34 square cable to minimize voltage drop. Holy shit. Yeah, especially nowadays, you'll pay yourself totally nuts in copper prices. That using converters like this at some point is just going to be cheaper. Because, oh wait, I can leave this side screwed in. Because the converter will be cheaper than the thick cables, basically. I'm wondering if we put this one in the middle and replace this one, basically. So we're going to do this. We're just going to swap the wires. This should be able to go in here. There we go. Strip these a little bit more. No. Okay. And there we go. Okay. So this one is now in the middle here, and this 10 amp one is now on the outside. Let's see what that does. Yeah, That's right, Shadi. I'd also go for the 10 amp ones, even on the edge connections, just to be sure. And then maybe on the middle ones, I'd go 15 amps, just so you know you have the headroom, that if something does fail, you're still not overdrawing it. So let's go to white, and let's go to maximum brightness. Yeah, we're still drawing 151 watts, so basically nothing changed. And let's measure the amps on this middle injection here. 8.49. So even though we have the 15 amp right here, and well, we can measure this one too, and a 10 amp on the edge injection, so 15 amp on the middle injection, we're seeing the same numbers. So my initial thoughts about using a 10 amp in the middle and a 5 amp on the outsides were pretty spot on. I personally, if I'd be building this for real life, I'd put a 10 amp on an edge connection and maybe use one of these cheaper plastic ones. That's fine. And then I'd put a 15 amp one on a middle connection. And if, for instance, if you're using a higher draw chip like maybe SK6812 because you also want to do some warm white and stuff like that, then certainly use a 15 amp for a middle injection. All the DC-DC converters are linked in the video description. Can you run multiple converters from one terminal off the quad? In theory, we're kind of already doing that because terminal 1 and terminal 2 on the positive side, don't know if I'm on screen. Yes. So terminal 1 and terminal 2 on the positive side are actually on one fuse. So same terminal, same fuse. Yeah. When running 60 meters of SK62812 using Dig-Quad, do you recommend splitting it into 4 times 15 meters and use 4 output channels or separate digital channels for each segment section? Let's talk about that, because if we go back to the website and we go to the digital LEDs, addressable LED section, there is an article called "What is the maximum amount of addressable LEDs per controller?" And if we look in there, I do calculations. If you use 100 LEDs, RGB, you can do 333 frames per second. But if you use 600 LEDs, we're doing 900 here, you only get 55 frames per second. And if you're doing 1,000, you only get 33 frames per second. And if we're talking WLED, it generally does 42 frames per second for the effects. So then you could use 793.6 RGB LEDs. We're doing 900, so we're actually dropping closer to that 33 frames per second. So the effects will definitely be less fluent than if we only had 600 LEDs. So in theory, I should have used a second data port. Now, if you're doing RGBW LEDs, and you want to keep the 42 FPS, which is what WLED does, you can only use about 600 before you start dropping below that frame rate, and it'll become, well, more visible that the effects are going to be, well, choppier, basically. So I hope that answers your questions, Uncom. I would think so. But yeah, all kinds of articles in the digitally addressable LED section. If you're having these kinds of questions, read through those, because there's a lot of answers there. So if we take this 600, that means you can run about 2400 RGBW LEDs off of a Dig-Quad before you basically saturate all the ports for data and keep the frames per second. That's not fully true, because there's also a maximum amount of that WLED can do, but it's pretty good. It depends on the effect you're doing and other kinds of things you have activated or not. But yeah, all the limits are in this article to design your setup, basically. SK6812 has been out for ages. When will we see some new chips? Well, we're nearing the 2-hour mark. So how about we share some secrets? Hey, do you guys want some stuff I've been working on behind the scenes? Want to see that? Ah, you're using 5 meter 150 LEDs. Okay, well, using those numbers, you can do the calculations. Teasers! No, no USB-C in this stream. I have been also working on that, but not in this stream. Yes, more likes is always good. Okay, so in this stream, we looked at doing 5 volt LEDs. You can't see my hands. 5 volt LEDs while feeding it 24 volt power and then using, well, this mess of buck converters here to make it 5 volt again, so that if you have long length LED projects, you can transport your power using thin wires with 24 volts and then just make it 5 volt where you need it. Right? Okay. But I've also been working on something else. I have bought, and I can show you a little bit of that already. I've recently updated the digitally adjustable LED sheet with the real world power. And we had a 5 volt sheet. We had a 12 volt sheet. But we now also have a 24 volt sheet. And that is for 3 types of 24 volt addressable LEDs. So I have some WS2811s, which are double row and 24 volt. I have some SK6812, so RGBW, which are 24 volt. And I have some TM1814, which is a new type of chip. It's generally a little bit cheaper, actually, which is also available in 24 volt. And, well, I've been doing testing on those, and I've made my typical chart on that. The downside, however, versus doing it this way you keep single addressable, and these 24 volt strips are per 6 LEDs addressable. So instead of being able to address each one of them, they are addressed in sections of 6 LEDs. In my opinion, if you're doing a very large-scale project where the LEDs, those 24 LEDs really don't want to sleep? What? But so if you're doing a very long project, maybe bumping to 12 volt, which is per 3 addressable, or to 24 volt, which is per 6 addressable, if that's 10 meters away, generally, I think that would probably be acceptable. Because then you don't have to do all this buck converter nonsense. You can just hook it up directly using a 24 volt power supply to a Dig-Quad V2, for instance, which does its own stuff on board up to 24 volts, no problem. And then you can run 24 volt addressable LEDs and use very thin wires and stuff like that. So that's kind of the teaser. I guess I could show you them. I'm going to make a dedicated video on this soon. Or soon at some point. You never know when soon is with me. So this is the SK6812 24 volt. You don't really see anything different about the strip, except that it says 24 volt on there. And that the sections, so you can see the cutting point here. Well, those are 6 LEDs per cutting point, basically. Right. These are already in the LED buying guide, and as I said, they're already in my power measurement sheet. And yeah, if you're looking to do long scale or long projects for away 20 meters, something like that, really look at 24 volt LEDs, or maybe a buck converter setup like this. So that's kind of the teaser that's coming. That I finally found 3 different strips that'll do 24 volt with my controllers, and that all works perfectly. The data boosters, for instance, are also 24 volt compatible. They're actually 48 volt compatible. And it just gives you more options to design your setup, either this way or using 24 volt strip directly. Let's see, DJ Dafia says, I want to do 25 meters of 12 volt WS2011 96 LEDs in one run. And they use 101 watts per 5 meter. I just want to run one wire of 25 meter long and tap into that wire at the injection points. You can do that. I'm generally not a fan of that. But the problem with that is you're doing 5 times 101 watts, right? So that is 500 watts. Divided by 12 volt, that is 42 amps. Okay, 42 amps, fine. If we go to our voltage drop calculator and we say we're doing 5 meters to let's say the first injection point, we're doing 12 volt. Oh, and we're doing what did I say? 42. We're doing 40 amps. Yeah, with 18 gauge, we're getting 69% loss. 69. So we're dropping 8 volt. Okay, let's go to 12 gauge. We're still dropping 2 volts. So that's not good. Let's go to 10 gauge. Okay, so you'd need 5 meters of 10 gauge cable just to go to the first injection point. And then you want to continue that cable to the second injection point. That is another 5 meters, but then it's not 40 amps going through that cable, but let's say 35, or yeah, something like that. So then you need another 5 meters of 10 gauge, and then it's the next will have to carry 30 amps, and then it'll have to carry 25 amps, and it'll have to carry 20 amps. So you're going to use a lot of thick copper, especially at the beginning, because the first part will have to carry all the power for all the other parts too. Then, once you pass an injection point, you can deduct some amps that'll be delivered right there. And then the second part will have to deliver all the amps for all the strips that are connected after that. And you never want more than 10% voltage drop per section of wire you need to calculate. So, although you can do one thick wire, I generally don't like that way. And yeah, you did the calculations too, and you'll need like 7 or 8 gauge. That is true, yes. And what is the best method to tap into a wire this thick? Strip some of the insulation, solder directly onto it, and then heat shrink it again or insulate it some other way. I don't know. Get some really thick terminals that you can use as a distribution block. Something like that, because you kind of also want a fuse per injection line. Here the Dig-Quad is taking care of that because it has a fuse per injection line. But if you have one thick line, you want a fuse for the total line, and you want a fuse per each branch line, basically. So you branch off the main cable, you want a fuse there at each point. So yeah, I guess that's why I generally don't like a one thick cable. Use a breaker as a WAGO. Yeah, because these type of clamps, 16 gauge maybe, not thicker than that. Yeah. Use an aluminium channel as ground. Maybe a copper channel, I don't know. Yeah, I like the converter setup, and I think it's actually okay to run with multiple converters with plus connected everywhere, as long as you oversize the converters, basically. So that if anything fails, one of the converters in between can't be over-asked, basically. So 10 amps on the edge connections and 15 amps on the middle, I think that would do it. I don't think you can over-ask that, basically, because then you're scaling up each side. So expected 5 here, let's do 10. Expected 10 here, let's do 15 or 20. I think then you're actually good. Oh, Andalage is here. Hey there. Oh, I totally forgot to call out Philip. Thank you for the donation, Philip. It was teaser time for sure. Maybe not as exciting teaser as normally, but 24 volt strips are nice too. Does Dig-Quad have a clock output for something like HD107S? Can I convert one of the data ports? Yes. So the data ports are just level shifted GPIO pins, so you can easily use one of the or two data ports, whatever, for that. Before we could only get one to work, one APA 102 clone or whatever. But with WLED 0.12, I've had reports of people being able to run two APA 102 style chips on a Dig-Quad, so then using the 4 ports. Arun Ankam, thank you for the $5, man. That's much appreciated. Are there now 12 volt per one addressable chips? Yes, there is. Actually, my wall display is WS2815. That is the only chip that is 12 volt, or one of the, I think there are competing chips, but basically that is 12 volt single addressable, but that comes at a cost. If we look back at my power usage sheet, wait. And we look at 12 volt, and we look at WS2815. First, let's look at 5 volt. 5 volt, right? If we do 100% red, it uses 25 watts. Same for green, same for blue. If we do white, it uses 65 watts. So it uses a lot more power because the red, blue, and green diode will be on at the same time. And we see that during effects, it varies a lot, 25 watts, 11 watts, 25 watts, right? Okay. Now let's go to the 12 volt sheet and WS2815. Here we see that 100% red uses 51 watts. That's a lot more. But 100% white also only uses about 50 watts. That's because it needs to drop down the 12 volt to something usable. So it has an elaborate internal LDO setup and constant current limiting combined with PWM, a bit too much to go into. But basically, if any diode needs to deliver 100%, it'll always use max power. And this shows in the effects. If we now look at Police All, that will use 50 watts the whole time. Loading, some LEDs are off, so it uses a little bit less, but Rainbow also uses about the maximum amount of power, like you'd expect for RGB white, but then for any pattern. Oh, Unexpected Maker is here. Welcome. Thanks for great work and sharing with us. Thank you, Morton, for the donation. That's much appreciated. So, 12 volt single addressable does exist, but it has its downsides, basically burning off a lot of power to drop the voltage for the LEDs to closer to 5 or 4 or 3 volt, whatever that LED needs with a constant current limit, constant current regulator and PWM and stuff like that. So, yes, it exists, but it's a lot less efficient. Another way to do it is if we scroll here, we go to the per 3 addressable and we look at WS2811, for instance. There we see again that if you use a single color, it draws like 30 watts, but if you then do RGB, it uses 75 watts. So even if you have a 96 LEDs per meter variant, it's actually still more efficient than single addressable WS2815 because of that having to drop the voltage and stuff like that. So, Unexpected Maker, we made a little bit of a mess on my desk today. We were feeding a Dig-Quad with 24 volts, and then we have a bunch of buck converters all connected together on the plus lines, which I generally don't recommend, but okay. And we're converting it down back to 5 volt and then driving a bunch of LEDs. Because if you have to transport 30 amps at 5 volt, you're going to need insane amounts of thick cable, while at 24 volts, that's okay. Is there a limit to data line length? I have a short run, 8 to 10 feet to the first strip, but then 15 meters of strip. Well, let's see what my website says about that. we go back to the digitally adjustable LEDs, and then we go to maximum length data wire for LEDs. Now, there's some prerequisites here. Basically, if you have a QuinLED-Dig controller, those are already met. And I've done a lot of tests on that and blah, blah, blah. Conclusion is 5 meters to 16 feet is generally fine. 10 meters is mostly fine, and beyond that, it can get a little bit sketchy. It also depends on what kind of cable you're using. If you're just using a normal single data wire, or if you're using a combined cable, so 2-wire or 3-wire, with ground next to the data signal, because that'll basically degrade the data signal over time because of transmission line effects. It's a lot of theory there. I also have an article about that. Don't know where it went. Oh, this article here. So you need to do some data signal conditioning, basically, because of the type of signal it is. The type of signal for the data signal isn't really meant to go long distances, but you can kind of finesse it a little bit to make it go longer lengths. Philip makes a good point. This is only of interest to the first LED you hit, because each LED in turn will propagate the data signal again to the other LED. So once you get a good signal to the first LED in your strip, all the others will follow along, and the distance between those two is pretty short, so that should work out fine. And 8 to 10 feet should generally be fine, even if you use 3-wire cable. So with ground next to the data signal, generally you should be fine with that. So just hook it up to a dig board, and that should work okay. If you're not using a level shifter and stuff like that, I don't know. Use the proper setup, otherwise I don't have an answer. It basically takes in the data signal, it strips off 1 LED worth of data, and then it sends out the data signal again. Yeah. Can you make the data go longer distances? So generally my answer to that is yes. If it's beyond 10 meters or 32 feet, we can extend it further, and you can use the data booster board. Let me show you that. So I recently released a board called a QuinLED Data Booster. That's this little thing which will boost, or basically take in the LED signal and send it out again strongly again. You can buy those in the US and in worldwide currently. But the problem with that is if you encounter outside influence or interference and the data signal corrupts, there's not much you can do about that. An F amp or a U amp or a Pixar booster or one of my QuinLED data boosters or something like that also can't fix that. If there's external corruption introduced into the signal, nothing can fix that. If you want to go beyond those lengths, or you're facing those kind of corruptions, what you can do is to convert the signal from single-ended to a differential signal. So then it'll go from a 1-wire signal to basically a 2-wire signal, and those are much more robust against interference and anything else that it would encounter along the line, basically. Also, then you can easily make a 50 meter or a 100 meter data cable. But will need a converter on one side to go from single-ended signal to differential signal, then have your long cable, and then go from differential signal back to a single-ended signal, and then put that into your LED strip. But yeah, that's a bit more advanced setup, basically. You could use those to repeat every 10 meters, and if you're lucky, that will work. But if there's any kind of interference anywhere, and the longer you make that line, the longer of an antenna you're basically making to find that interference, yeah. Any point in a shielded data cable? Not that much. If you're running a cable with ground next to the data signal, you're basically already creating a transmission line effect, as it's called. Again, that's explained mostly in this article here, the myth of the data LED resistor. So if you use the right type of resistors or a data booster board, that gives you some little bit of a protection, but it's not the same as a differential signal. So I'd quicker invest in changing it to a differential signal and then changing it back again at the other end, which of course needs active hardware, so it's going to cost you, than trying shielded cables and stuff like that. Yeah. Yeah, so symmetric data signal, twisted pair and shield around it, sure. But convert it to differential first, otherwise it won't make a difference. My Coke is almost done. It means the live stream is almost done. Also almost done. I'm forgetting how to talk. Oh, sorry about that. I converted to a differential signal, but ultimately just moved my dig closer to the injection point. Yeah, so my boards are generally cheap enough that you can just buy another board and put that closer to where your LEDs are than converting it to differential and then converting it back again, because the cost of doing that is likely the same or more expensive than just getting another board. But it would depend on the situation, I guess. A cat cable, if you have the Ethernet version, you mean, Tim? Otherwise, it's wireless. So yeah. That cracked me up. My speech impediment is cracking you up, Joey. Don't worry, I took a sip. Now I can talk again. That's fine. Right, so let's give it another 6 minutes. Then it's 11:15. Quinder, would you be interested in a joint venture? I want to do the front of my house in LED strip. Maybe you can do it together and you can make a series of how-to videos. I'm from the Netherlands. It's interesting, but I generally am way too busy anyway, so I think I'll pass on that. I'll give it some thought, but are you in the Discord? But generally I have to pass on that kind of stuff because it eats too much time, basically, but yeah. Oh, I wanted my dig and PSU in one box on the wall, midpoint for power distribution. But doing the data signal for 20 meters didn't work well at all, no matter what I did. Yeah, I can understand that. With the data booster now, and being able to set it to 33 ohm, or replacing the resistors on the board to 33 ohm, and then running ground and data signal together, and maybe using 18 gauge cable uninterrupted, you might get there. Yeah, 20 meters is just, I'd say anything beyond 10 meters is, I don't recommend. Right. I'm actually pretty happy with how this is working. It's still working. Let's up the brightness. What are we drawing? 30 watts. Huh. Yeah, exactly, Philip. You can't have any interference along the way, and you can't cross any AC lines, and I don't know what kind of signals. Anything could happen to interrupt it, basically. So, it's just blowing out the camera now. There we go. Yeah, so if you want to do large projects, DC converters, yeah. And I think you'll be okay connecting them all together. I'm sure an electrician will still tell you not to do that. Actually, I will tell you not to do that. But if you oversize everything, yeah, I guess the worst that can happen if you use proper fuses is that your fuse pops. What about a higher voltage than 24 volt as buck converter input? You can do that, but the board, the current Dig-Quad and the Dig-Uno V3 and Dig-Quad V2 pre-assembled, they're rated up to 24 volt, partly because I wanted to be able to do this scenario and I wanted to be able to use 24 volt addressable LED strip. So higher than that, you'll have to run all the power wires separate from the board and have all ground still connected. And you'll have to do your own power distribution and your own fusing and stuff like that. And you'll have to step it down for the board too, because that shouldn't see higher than 24 volts. Now you can use a separate power supply using the 5 volt EXT connectors, for instance. That would work too. But yeah, board 24 volt max. And well, you can already see it's a 5 times difference in the amount of amps. Of course, you can go to 48 volts, and then it's about a 10 times difference. But yeah, at some point, I think 24 volts would generally be enough, because we can look at that. Because voltage drop also becomes less important. So let's say we take 18 gauge, which is a decent size wire, and we want to do 20 meters, and we have 24 volts, and we want 20 amps in the end. So if we do a calculation for that, if we want 20 amps at 5 volts, that's 100 watts, okay? But we divide that by 24, that's 4.1 watts, amps. So let's say we want to do 20 meters of 5 amps. Generally, I'd say you want to stay within 10% of voltage drop on your cable. But that is because they're connected directly to an LED. And well, that is then what the LED is going to see. So if you feed it 5 volt and you drop 17% or a few volts during the way, that LED is only going to see 3.8 volt. That's not enough. But if we're feeding 24 volt in and we're ending up with 20 volts at the end, well, this converter is going to down convert it to 5 volt anyway, and it doesn't really care if it sees 24 volts, 20 volts, or 16 volts. So yes, we're losing energy in that cable, but it's not having the same effect as that our device or LEDs would be directly connected to it. Because the converter will still give you a solid 5 volt, and if you're not doing that 100 watts, but you're doing 30 watts because you're running some kind of LED pattern, the voltage drop won't be nearly as much, and just in the worst case scenario it would be that 4 volts, but that would be a very workable scenario for me. So it's different driving buck converters at the end than driving LEDs directly at the end. Hope that makes sense. So yeah, you can do higher voltages, but at some point I don't see the use anymore, basically. Yes, I would have to redesign the whole circuit for making it 48 volt compatible. And there are no 48 volt LED strips, so I don't think that's going to happen anytime soon. But yeah, you can if you want to, but you'll have to do it externally. Another guy says, so on my strips, there's a separate power lines along with combined 4-wire connectors, data, clock, etc. Is there any point in powering both separate and combined connectors? So what we're doing here is we have that little JST connector connecting the strips together, but then you can see the red and white wires here, and the red and white wires, well, you can't see it, but from the other strip, we use those to power inject them. So that way, it's very easy to wire up. So you could use those combined, but in this case, it won't make that much of a difference. $220 volts for the win. Yeah, let's not. Yeah, 48 volt buck converters also get more expensive. I believe these are officially, yeah, they're 20 to 24. So 24 volts, I believe they're 30 volts max or something like that. So you definitely need different ones too, and that will probably cost you more. Absolutely. A per 12 addressable strip. Yeah, I don't think they're ever going to make that, because 24 volt is already pretty high, and then the receiving LED, yeah, I don't think they'll quickly do that. And yeah, I mean, we just calculated 20 meters with 18 gauge. I don't think that's that bad for 100 watts. So that's 20 amps, and a single injection point between two strips won't use that much more than 10 amps. So calculations are probably even more favorable. Do the buck converters make any noise? No, zero. Not on nothing. 12 addressable LEDs, you'd be better off with analogs. Yeah, I don't know about that, but yeah. They'd be addressable per half a meter. I don't know, man. Yeah, I'm actually quite happy with this. I'll be writing more articles on this and probably do a dedicated video. Yeah. Still, officially, I don't think you should do it. But unofficially, I think it'll work fine. And it's different than hooking up two power supplies to one strip. But yeah. Cool. Well, I think we've run through most of the questions. I had a good time hooking all this up and testing it out. And I'm pleasantly surprised it worked that smoothly. And, yeah, I think we'll end the stream there. So, I thank you all very much for watching, and I hope to see you back on the Discord server, in the comments, in another video, in another live stream, or wherever we might meet. So, thank you all very much for watching, and catch you guys next time.